Welcome back. I want to finish up chapter 8 here with making sure you understand the 4 types of chemical reactions and how to use them. All right? So the first type we want to talk about, when we talk about a chemical reaction, is how we look at the reactants on one side and the products on the other. First type is called a synthesis reaction. Synthesis means to put together. To synthesize is to put stuff together. And it has a form, kind of algebraic, but basically you got one reactant and another reactant and it yields one product. So you have more than one reactant, but what you get is one thing. These things get put together. The point of these 4 reactions is your ability to recognize what type of reaction is going on. So you see something like if we combine iron with sulfur, all right, and that yields iron sulfide, then this is an example of a synthesis reaction. 2 reactants, 1 product, all right? Perhaps the simplest types, all right? And yeah, anytime you see this pattern, 2 things become 1, that's a synthesis reaction, all right? Now the opposite of a synthesis reaction, all right, is a decomposition reaction. Decomposition, like to decompose, to break apart, to get simpler instead of more complex. And that says you start with 1 reactant, and that yields, breaks into 2 or more products. Starting with 1 breaks into 2, all right? If we were in school, we would do a lab where we would break apart water using electricity. We would take H2O and, well, 2H2O and zap it with some electricity and get 2H2 plus O2. Yeah, there we go. Starting with 1 thing, breaking apart into 2 things. That's how you recognize a decomposition reaction. All right? Now, the next 2, slightly more complicated, but not really. All right? We talk about something called a single replacement. Single replacement reaction, all right? So here you have 2 things going on. You have some sort of reactant plus another reactant, and we see a switch happening, all right? We see that this element here is going to get replaced so that we have AC plus B, all right? One switch in the idea, single replacement, all right? That's something like, and this we would have done in the lab too, is to add zinc to hydrochloric acid, nasty stuff, all right? So we've got 2 reactants, all right? And notice that what's going to switch here is the zinc and the hydrogen so that we get zinc chloride plus the hydrogen. And we ask ourselves, is that balanced? Yeah, we got 1 zinc here, 1 zinc there, 2 hydrogen here, 2 hydrogen there, 2 chlorine, 2 chlorine, all right? But the idea is that you've got a single thing here and now a different single thing there. Focus on the word single replacement, all right? Single replacement reaction. And the final one is called a double replacement. A double replacement reaction. And in that, we've got a compound plus another compound yielding, and now notice there's no single things here, all right? That's how you tell a single from a double, all right? Remember here, you've got a single thing, And that yields another single thing. Here, we're starting with a double thing and we're just switching it so that A goes with D and B goes with C. Double, double yields double, double, except there's been a switch, all right? Example of that would be something like magnesium plus hydrochloric acid yielding MgCl2 plus H2CO3. All right. Double replacement. Notice you've got a compound plus a compound yields another compound and another compound, but we've had a switch here. This Mg has now been switched with the Cl. And the CO3 now goes with the H. A double replacement. All right? And so you would be tasked in high school chemistry to be able to recognize these types of things. All right? So if we write a bunch of equations on the board and we see 2Al2O3 yields 4Al plus 3O2, what kind of reaction is that? Well, I mean, you notice that there's one thing to begin with and two things to end with. So this is a decomposition reaction, right? We could do something like Ca plus 2H2O yields CaOH2 plus H2. And we look at that and we see a single thing here and a new single thing there. So this is a single replacement reaction, right? As opposed to more complicated stuff, AgNO3 plus NABR yields AgBr plus NaNO3. So we look at this and we see that's a compound, AB, that's another compound, CD, and what's happened? The AD, which used to be with the NO3, got switched. The AG is now with the BR. The Na, which used to be with the Br, is now switched with the NO3. So this is a double replacement reaction. And then finally you could say something like 2Na plus Br yields 2NaBr. Two things go in, one thing comes out. That is a synthesis reaction. All right. So this is the last lesson in Chapter 8. All right. There will be a Chapter 8 test to take where you'll be asked to recognize this type of stuff. So your assignment is simply to read these pages. You can use the review at the end before the test, which would be a good thing. All right. And then take the test and you'll be all set for high school chemistry next year.